Okay, welcome back to day 6 of summer school geometry. Today we're going to be talking about properties of parallelograms. So we're going to cover the special characteristics of all parallelograms and all the different properties of them, and then we'll work some examples. So in this open area here, I'm just going to sketch a parallelogram. So the reason a parallelogram is called a parallelogram is because it has two sets of parallel sides. So I'm going to draw two lines that are parallel, and I'm going to label them as such. And so the way we label two parallel lines is by marking them with these arrows in the middle of the line somewhere. And then a parallelogram is a four-sided shape where both of the opposite sets of sides are parallel to each other. So if there's a new set of parallel lines, we mark them with another set of arrows, so double arrows here. And this is a parallelogram now. Another interesting thing about a parallelogram is that the opposite sides are also the same length. So we mark that with straight lines like that. So these two opposite sides are the same length, and then these two opposite sides are the same length. We can also talk about the angles. The angles on opposite sides of the parallelogram, opposite corners, are going to be congruent to each other, and same thing over here. These two guys are congruent to each other, so that's another characteristic. And then the last thing that we also want to take note of is, let me label the four corners with letters A, B, C, and D. If I just focus in on angle B and angle C, I'm going to say the measure of angle B plus the measure of angle C. If you have two consecutive angles, meaning two consecutive means they're next to each other on the parallelogram, not across but next to, those two angles will always be equal to 180 degrees. And the same goes for if you look at A and B or A and D or D and C, they're always going to equal to 180. So I'm just going to mark right here, consecutive angles are what we call supplementary. And that means that they add up to 180. Add up to 180 degrees. All right. So let's work a few examples that involve parallelograms. In this first example, it tells us to find three different things. Find the measure of angle A, angle D, and find the length of segment AB. So let's first start by finding the measure of angle D. I'm going to go across because that's the easiest one. If you know angle B is 127, you just go straight across, and the measure of angle D is the same thing. Now we look at angle A. Angle A is adjacent or next to angle B, so I need to see what would add up to 180. Measure of angle A is 180 minus 127, which is going to be 53 degrees. So angle A is 53 degrees, and I can check that by adding these two up, and I should get 180. And the last thing is find the length of AB. And I noticed that AB and CD should be the same because it's a parallelogram. So these two opposite sides have to be equal to each other. So those algebraic expressions, let's just set them equal to each other and solve for x. So that means that AB, if AB is equal to x plus 2, then I found out that x is equal to 5. So AB should be 5 plus 2, which is equal to 7. And there's the measure of line segment AB. Let's keep going. So here we have this parallelogram. I'm going to mark those guys as parallel. And we have these segments going across through the middle. These are called diagonals. They're going diagonally across from one vertex to the opposite vertex. And so we talked about how we had these angles forming, but now if we have these diagonals forming, I need to start to kind of piece things together. We want to figure out what angle 1 is, angle 2, and angle 3 are. That's where I want to get to. So let's first start by figuring out what we can. In general, a triangle, the three angles will always equal 180 degrees. So starting with that idea in mind, I'm going to fill in the opposite angle here. If this is 75 degrees, then the opposite angle should also be 75 degrees. So now I have 75 plus 50 plus whatever this is. So the measure of angle 3 has to be whatever I could add up to 75 and 50 to get 180. So 75 plus 50 is going to be 125. And I need 55 more degrees to get to a total of 180 degrees. Now if I look at the other two angles, I have angle 1 and angle 2. Now notice that this was also 75 degrees here. Using the properties of parallel lines, since I have this transversal going through here, thinking about if I had this parallel line and this parallel line, I have a transversal going through here. I also have another transversal going through here. This gives me some special characteristics of these triangles formed within here. I can now think about how these angles 1 and 3, those are going to be alternate interior angles. They're on the interior of the parallel lines and they're on alternating sides, so they're going to be congruent. So angle 1 also has to be 55 degrees. Measure of angle 1 equals 55 degrees. And now I just think about what angle 2 is here. We know that 75 and 75 are equal here. That means these two have to be equal as well. So 75 plus 75 is going to be equal to 150. These two angles are making a full circle around here. So if I think about these two angles, notice how this makes a full circle. So these two should combine with these two to make 360 degrees because that's a full circle. 75 and 75 make 150 degrees. We need to get all the way up to 360. So over off to the side, I'm going to say 360 minus 150 is equal to 210. And so if these two have to be totaling up to 210, then I just divide that by 2 now. So 210 divided by 2 is equal to 105 for each of those, 105 and 105. So now I get that the measure of angle 2 is equal to 105 degrees. All right, same thing here. What we can do is set opposite sides equal to each other if we're trying to figure out what the length of each side is. So opposite sides, 4x minus 30 equal 2x minus 8. That's going to get us these two sides. To get the other two sides, we need to do 12y minus 1 is equal to 4y plus 7. And so let's go ahead and solve both of these. Okay, so now that we've solved for both x and y, we need to plug them back into QR and RS. So here's QR, it's 4y plus 7. And we said y is equal to 1. So 4 times 1 is 4 plus 7 is 11. So QR is going to be 11. Then we have RS. RS is 2x minus 8. And we said x is 11. So 2 times 11 is just 22. 22 minus 8, which is going to be 14. And there's QR and RS. Okay, so now what you need to do is you need to go back to Canvas, click on the module and you'll see the directions for today and the assignment. Go ahead and complete that assignment. And as always, if you have questions, please don't hesitate to email me. My email is right here. Feel free to reach out if you have any questions at any time. I'm happy to answer.